The function x squared plus 6x plus k is defined for x element of real number. So this is what we call as the domain is not restricted because I can take all the element of real number. Now what do they want? They want me to find the range for the function in terms of k. Let's look at the second question. It is also similar. They gave me a function g and they are telling the x is element of real number and I need to find the range of g in terms of a. So how do I approach this question? Step number 1 is finding the turning point. How do you want to find the turning point? You could do completing of square or differentiation, or you could use formula. Okay, for the start, I am going to do completing the square. For those who are unsure why I am doing this, what is the meaning of x squared? It is like an area with side length x and x, like that, x and x. Now you need to get an area of 6x. So how will you get that? Of course you will extend a length of 3 unit here and 3 unit here. So now what is the area of this part? 3x. What is the area of this part? 3x. So in total you will get your 6x. Then what do I do with the k? So you pause the k first. We're going to complete the entire square. And what is the area of this whole square? You look at the side length. The side length is going to be x plus 3. So the area of the whole square is going to be x plus 3 squared. But then I have a portion which I don't need, which is this one. Do you need this? No, right? So you eliminate that. You remove from your area, which is minus 9. How do I know? 3 times by 3. I'll get the 9. Then what am I doing? I'm writing it in this expression, the area of the square. Then I am maintaining my k. Okay, this is one way of doing. If you are not very good in completing of square, you could even do differentiation and find the turning point. So step number 1, I differentiate 2x plus 6 equal to 0. If you're not sure, I'm taking this. And my x is equal to minus 3. So from here you will get your y value by substitution. Negative 3 squared plus 6 negative 3 plus by k, which will give you k minus 9. And you know that when you are differentiating and you are giving the gradient to be a 0, it will give you the turning point. So what is the turning point of this function f? It is negative 3 k minus 9. I'll explain why am I doing this in a while. I got my fx. Now I need the range. And I know that this is a quadratic. This expression, this function over here, it is a quadratic which is of smiley parabola shape. So let's try to illustrate that. My turning point is negative 3 for x value. And I'm not sure what is the value of the k. But I know on my x-axis, I need to locate the minus 3. Where is k minus 9? We are unsure. But I know it is on the y-axis. For a start, I'm going to put it here. Let's say this is k minus 9. And I know this question, the y-intercept. Where will it cut the y-axis? At the y-axis, your x is equal to 0. So when I do that, my f0 is going to be 0 plus k, which is the k. Okay, they did not say anything about the k value, so I'm not sure whether k is positive or negative. I'm going to assume k is positive or on the positive y-axis. So let me label it here, then I'm going to sketch it. Okay, so this could be my y-intercept, which is the k. From here, you want to find the range. What is the idea of range? You need to locate the lowest y value and also the most highest y value. In this quadratic curve over here, what is your lowest y value? Isn't it k minus 9? And anything greater than that? So the solution of this is going to be y more or equals to k minus 9. That is the answer for the first part. Why did I do differentiation? Because I wanted to plot it. Why did I do completing of square? Because I want to get the vertex from here, which is the turning point, negative 3, k minus 9. And then I can use it to sketch. Just now we were not sure whether your k is going to be on the y-axis, positive part, or below the x-axis, on the negative y part. Okay, let's say if you are not very sure, what could have happened if you were to draw this somewhere at the bottom? If I were to do this, I would have plotted this part as my k minus 9. And I know still the lowest value is k minus 9 for the y. My minimum y value is k minus 9 and my range is anything more than that. So if you're not unsure, it's okay. So how do I do this quickly? Step number 1, you get your turning point. You could do differentiation or completing square, or you can even use the formula. Step number 2, you detect the shape of this, whether yours is going to be a minimum graph or maximum graph. Then you can make a conclusion. If it is minimum, then your inequality sign is going to be greater than. Whether you need to put the equal or not, you look at the question and you analyze. That's all. Let's try with question number 12. Similar method. So for 12, I'm going to do differentiation to find the turning point. So let's do g prime x is minus a minus 4x equate to 0. It's minus a over 4. Now let's find the y value for it, or the gx. This one will give you a squared over 16. Okay, that is my gx. So now go and see, is it a minimum or maximum graph? Look for the coefficient of your x squared. So it is negative 2, and you know that it is going to be a maximum graph. So if it is a maximum graph, okay, let's do. So this is number 1, step number 1. Our step number 2 is, you know, it is a maximum graph, and maximum graph will have this shape of parabola, and this is the highest y value that you can ever get in the graph. So you know that that y value is 5 plus a squared over 8. So now you are locating for the range. Where will the range be? Okay, let's just create the y-axis, and you know that this is your y value, and you will be taking anything lower than that. If you want to be very precise, then you check on your x value over here. We are not sure whether our a is positive or negative. So whether the x will be on the right hand side of the x-axis or left hand side of the x-axis, you are not so sure. But that doesn't matter, because you know your maximum y is equal to this. What is the minimum y? We don't have one, because the graph will just get extended at the bottom. So I know my final answer is going to be y less than or equal to 5 plus a squared over 8. I hope you see it now. When the question is having no restriction on the domain, so if it is a minimum graph, then you are using more. If it is a maximum graph, then you are using less.